Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 12, Part 5, multiple linear regression, qualitative independent variables, and interaction terms. All right, we're in a situation where we're comparing two different models. One model has main effects only, and one model has main effects and it has interaction terms between dose and drug. So remind yourself of these two models from earlier in the chapter, and we're going to write out each of the models for all the different drugs. Okay, so in the main effects model, drug A, we get y hat equals 3.35 plus 2.77 times dose. Drug B, y hat equals 3.35 minus 1.30 plus 2.77 times dose. For drug C, we get y hat equals 3.35 minus 3.05 plus 2.77 times dose. All right, so essentially here, if we put dose on the x-axis and we put the response time on the y-axis, right? For drug A, right, we have a positive slope of 2.77 and we have a y-intercept of 3.35. Right? So here's drug A. For drug B, 3.35 minus 1.30. So that's close to 2, but we have parallel lines. This is drug B. And then for drug C, there we go, drug C. So in the model with main effects, the slope in each of these cases is 2.77, but the difference is that the y-intercept is different. So essentially for a fixed dose, right, the relationship, if we're going to fix the dose and then increase by a certain amount, right, then this slope is the same regardless of which drug that I'm using. However, the response time is affected and shifted, right? That's the model with main effects. All right, let's look at the model with main effects and interaction terms. So let's write this out for drug A. Y hat equals 1.98 plus 4.60 dose. Drug B, y hat equals 1.98 plus 0.41 plus 4.60 minus 2.28 times dose. Drug C, y hat equals 1.98 minus 0.66 plus 4.60 minus 3.19 times dose. If I reduce this down for drug B, I get y hat equals 2.39 plus 2.32 times dose. And for drug C, I get y hat equals 1.32 plus 1.41 times dose. So in this case, if I draw a profile plot of the dose and the response time, all right, I get a value of a slope of 4.60 for drug A, and it intercepts at 2 approximately, right? So here's drug A. And for drug B, I get 2.39. So we have a higher y-intercept. And then the slope is 2, so it's not quite as sharp. Here's drug B. And then for drug C, I get 1.32 for my y-intercept. And I have a slope of 1.41. So it looks something like that for drug C. So in this case, I no longer have parallel lines, which tells me that I have an interaction term. So plotting out these lines can be very helpful for interpreting the coefficients. I hope you learned something today, and I'll see you next time.